morning, Grant.
Yellow.
There's Alexander. Good morning. Everybody rolling in. Good. Give another minute, see who shows up. Okay, we got 4 of you here, 5 now. All right, guys, we'll go ahead and get started. And here they come. All right. Yesterday, if you did the Ed Puzzle video, that is due today, by the way, at 3 o'clock. Make sure you get those done if you haven't. But hopefully those videos made it a little bit clearer about how a basic DC motor works, and the starter video with some of the specifics to the starter motor itself and some of the other things besides the motor that's actually going on there. So there's other components making that starter work and working all together to start the vehicle. So again, hopefully that made better sense than me trying to scribble pictures up here and show you pictures, and doesn't really do it justice. The animations I thought in those videos were very good. So hopefully that helped you guys. If you haven't done it, make sure you get it done by this afternoon. Again, reminder, Friday is midterm. If you have missing assignments, make sure you get those in by Friday at 3 for them to get counted on the midterm. If you haven't done them, get them in. If you do have them all done, great. Congratulations. That's what I like to see. None of the assignments are terribly long, terribly difficult, but if you get backed up, get behind, it can take a little while to work your way back. So make sure we're doing that. Get caught up and stay caught up. Okay, it's easier to stay caught up than it is to spend a lot of time at the last minute to try to get them all done. So, okay, we're going to finish up discussion on the starting system today as far as the fundamentals of it. Tomorrow we will have the Chapter 30 quiz. I will also assign the Chapter 31 review questions. Chapter 31 deals with diagnosis and repair of the starting system, some of the symptoms of failure of the starting system, and what to look for and what to do to take care of those problems. So that's what we'll be starting on tomorrow. After the quiz, I will assign the quiz, and then I'll assign the chapter and review questions as well. So anyway, the review questions, I'm not going to make those due on Friday. That'll probably be a Monday thing. But the quiz will be due on Friday at 3 as well. So if you have still assignments you're trying to cram in here too, you need to get busy. Okay, so anyway, starting system, and I'm going to go ahead and present my screen. And should be able to see this. And I'm just going to go through and highlight a few things here, and some of the things we talked about. Now, in the book and even in that video yesterday on starters, they showed a very simple, very basic circuit to control the starter. Before we end today, I'm going to show you a wiring diagram of a modern car with a push-button start, and I'm not grading you or anything on it. I just want to give you a kind of a look at what's involved in starting a modern car and the computer system controls of that system. So we'll take a look at that, and I'll talk a little bit about that, kind of introduce you to that kind of stuff to let you know what is out there and what's going on with cars these days. So, okay, so the screen here, armature and field windings. The field windings are a fixed polarity magnetic field. It doesn't change. It's always the same. And those electromagnets, I should say, are mounted to the inside of that starter housing. Our armature and commutator and brushes, the armature windings, work together to create a magnetic field that is changing. And that changing magnetic field continuously repels away from the armature windings, or the magnetic field of the armature windings, and causes that motor to rotate. Okay, and that's basically what's going on there. Move forward here. Things going on here. There we go. Everything else, the book pretty much the book covers, the videos covered. The starter solenoid, talk about that real quick, just to cover the operation of it. Probably the most common cause of a starter failing is in the solenoid. The solenoid has several functions. The two main functions are, first of all, engaging that pinion gear with the flywheel. Okay, that starter solenoid has to move that flywheel, or move the pinion gear into the flywheel to engage the teeth so that that starter motor can turn the engine. The second is to handle the high current load of the power to the starter. We talked about the operation of a relay, and that's exactly what's going on in here in the starter solenoid. We're using a small current supplied by the ignition switch to control a large current that powers the starter motor. Okay, if we had a switch large enough to handle the current from the starter motor, it would be a very large switch, not very easy to put inside the interior of a car. So we have a small switch controlling a large current through a relay or the starter solenoid contacts. And we'll see again how we can, because of this, a small current controlling a large current, we can see how that, we'll see in a minute how that adapts to computer control of our starting circuit. Computers do not control large current directly, at least most of them. There probably are some that can handle that, but it's typically done through a relay. And we'll see that here in a few minutes. I want to cover a few more things here. So, okay. So the main parts of the starter motor, the armature, and that's the windings that are moving, rotating inside that starter, the commutator end frame, that's the contact point, or the commutators, the contact points for the armature coils. Okay. And there's a starter mounted solenoid again, showing the mechanism, the lever that pushes that pinion gear away from the starter and into the flywheel gears, and shows the contact points controlling the large current using a small current. Okay, so I want to talk about permanent magnet. Okay, permanent magnet starters. The starter we've talked about and the starter in the video used a wire wound magnets and electromagnets inside there for the stationary magnets. Okay, those are very reliable, but they're big and bulky, and the larger the more torque we need, the larger those coils have to be. Uh, in most cars these days, I could probably say all, but I can't confirm that every single one does this. But to downsize the starter, because cars are smaller, engines are smaller, everything's downsized. Uh, Starters use permanent magnets instead of wire wound field magnets. Okay, permanent magnets are made of material that does not require electricity to provide magnetism. It's by its nature that material is magnetic. So we don't need to supply electricity to create a magnetic field for our armature to rotate through. It's permanent, it's always there, it never changes. Uh, and with the strong power of the permanent magnets, we can make the starter a lot smaller. And because of that, we can fit it into tighter places, smaller engines, things like that as we downsize cars. A couple things you need to be aware of with a permanent magnet starter. Okay, the magnets themselves are a very brittle metal, and I don't know if you've ever played with magnets, speaker magnets or something like that, if you've ever taken those apart and played with them. It's the same type of material. It's a very brittle material. Um, if it gets dropped, it can break. If you're servicing something on a car where you need to take the starter off to get to it, be careful and not drop the starter. Those starters can break. The internal magnets can break, and you may not notice it. You won't see it from the outside, uh, but you'll know as soon as you try to use that starter and it doesn't work. Um, so be careful. Don't drop them. The other thing you need to avoid with a permanent magnet starter, and this used to be uh, common practice, if the starter was failing on a car, maybe the solenoid was sticking or not making good contact, or uh, the brushes were worn and not making good contact and the starter wasn't working. It used to be common practice to roll under the car and try to hit the starter with a hammer and jar everything loose and make it work. Um, on a wire wound field coil, that's fine. You can do that, and you're not going to damage anything unless you're really pounding on that thing. But with a permanent magnet starter, if you do that, you're probably going to destroy the starter. Okay, the magnets inside there will break, and there's no replacing those magnets. They're bonded in, glued in as a permanent part of the starter. So if you have, like, maybe you've got a sticking solenoid, or maybe you've got a bad connection, and you don't diagnose that, but just first thing you do is roll under the car and start smacking the starter with a hammer, thinking it might make it work. You may have just created a second and very expensive problem for yourself. So don't hit them with a hammer. Don't drop a permanent magnet starter. Okay, just be careful with them, and because they are not cheap. Starters for a lot of cars these days go for $200 or $300 a piece to replace them. So, what else I'm gonna cover here before we're done? Neutral safety switch. The purpose of that neutral safety switch, whether it's an automatic transmission or a manual transmission, is to prevent that starter from engaging, prevent the car from starting unless the vehicle is in park or neutral. Okay, park or neutral for a automatic transmission, and neutral for a manual transmission. A manual transmission vehicle might also have a safety switch on the clutch. Uh, some automatic transmissions may have a safety switch on the brake. So depending on the manufacturer, you could have more than that. But the neutral safety switch is designed to keep that vehicle from starting unless it is safely in park or neutral. Okay. There's a diagram. It's very simple again. Looks just like the diagram we saw before with just the starter switch, but in line, in series with the starter switch is the neutral switch. So both of those switches would have to be closed to allow current to flow to the starter solenoid. Okay. And here again, this is our starting system circuit. Very simple: battery, starter relay, neutral switch, starter solenoid on the starter. Okay. Not too much to it, but here's where this up here. Wait a minute. And again, I just pulled this out of all data, and you'll have to excuse my splicing of the two images. I had to screenshot it. The all data won't let you save one of these pictures. So anyway, so here is the diagram, top to bottom. Okay, up at the top here, this big box, we have the why does it do that? I'm not sure why it keeps doing that. We have an electronic module called the IPDMER. Okay, intelligent power distribution module. And if we move down here, we have a body control. Dang it. For some reason, some pictures on here, it does weird stuff. So we have the body control module. And as I said, this is a push button start. So down here, we have our push switch. And that's the main input. You push that button to start the car. And that push switch is not directly controlling the relay. It's not directly controlling the solenoid. That push switch is just an input. And we can see if I follow the black wire from the push switch, it would go down to ground. But the red wire goes to the body control module and also goes to the intelligent power distribution module. And that's just a fancy way of saying it's an electronic module inside the fuse panel. So those two modules combined start the vehicle. Okay, they receive an input from the switch. Okay, the computer sees that switch being pressed. Because it does go to ground, it pulls that circuit down to 0 when we ground it. And the computer sees that and sees that as a signal to start the vehicle if other criteria are met. We have the transmission range switch over here. Okay, the transmission range switch is another fancy name for a neutral safety switch. It does more than that, though. It also provides an input for gear position and other information to the transmission control module. So we've got a lot of inputs going on for this vehicle to start. And I'm going to point out a couple more here. And right, oops, I need a smaller. Right here and right here, computer system data lines. every module on a vehicle, every computer on the vehicle is connected to the others over a network. Um, just like computers, in a building might be connected through a network. They can communicate with each other and share information. So I don't have a list. All data doesn't provide a list of the modules that are supplying information to the BCM and power distribution modules. Uh, but it's a good guess that these two modules are also looking at information from other modules. They may be taking information from the engine control module, from the anti-lock brake module, and other modules on the network to gather enough information to determine whether that engine should be started at that point. Keyless entry might look at that. Anti-theft system, it will definitely be looking at that. So a lot of information is shared over the network. And again, it's not just a simple switch controlling a solenoid, controlling the starter. This gives us the benefit, even though it is more complex, it gives us the benefit of having uh, a lot of other conveniences. This system here, and I know from experience, this is a Nissan Altima. Uh, they originally did not come from the factory with a remote start, because the uh, keyless entry system is on the network. The starting of the engine is simply controlled by an input to a computer. To add a remote start to this, it just took basically replacing the key fob, your push button that you use to open the doors, replacing that with a fob that had a start button on it, and then going in and reprogramming the computer and telling it when it received that input from the keyless entry uh, key fob that it would start the car. So it gave the ability to not add any hardware to a car, but they could add a remote start system simply by reprogramming the computer. So there are advantages to it. And I'm going to go in and again, this is a little beyond what we're talking about in this chapter, but this image here, and it extends on for a little ways here. This is showing all of the modules in that car on the network. Over on the far left, we have engine control module, ABS, power steering module. Towards the center, we have steering angle sensor, airbag diagnosis unit, combination meter, which is the instrument cluster, uh, air conditioning, body control module. Over here, we have our, zoom that in a little bit. Over here, we have our side radar for left and right. We have sonar, distance sensor, and ADAS, which is collision avoidance. So you can see there's a lot of computers on the network, and they share information with each other. And again, I don't have a list, and I'd probably have to go to an engineer to find out exactly what data everything is required to cause that vehicle to start when it sees that push button input. But just you can bet that it's looking at many different things throughout the car, and does it very quickly. It does it in a split second. As soon as you push the button, of course that computer data travels at the speed of light, so it is very quick, and you don't even realize it's happening. You don't have to wait around for this to happen. All this happens in a split second, and the car starts. So just to give you a taste of what modern cars are like, and this is just one system. The sharing of information goes on in many modules. The instrument cluster receives vehicle speed information from the anti-lock brake module so that the speedometer works. Okay, just a lot of things like that go on. The networking kind of makes it better. We don't have to have redundant sensors. And going back to the vehicle speed, it used to be the speedometer had a speed sensor. The transmission control module had a speed sensor. Sometimes if it was an all-wheel drive vehicle, that system would have its own speed sensor. So now we've consolidated that. We don't need all those multiple sensors. We can get information from one module, and that can be shared with all the other modules that need that information. So again, that goes beyond a little bit beyond this, what we're talking about this chapter, and this won't be on the quiz, but I just wanted to show you again what's going on out there, and how the simple circuit in our book about the starters has evolved in modern cars. So any questions on that? All right, tomorrow, again, we will have the quiz on chapter 30, and the review questions will be posted as well to get a head start on that. We're going to start moving through some of these chapters, hopefully a little bit quicker, because at the pace we've been going with having to do remote learning and everything, it's kind of slowed us down. But I'd like to go through some of this stuff a little quicker, so we'll move on to starting systems and diagnosis and repair, and then we'll probably move into charging systems. We'll cover all three major electrical chapters with the battery, starting and charging. So, okay, any questions? All right, it is now 9:57. I'm going to end this here. Okay, and again, missing assignments, get them in. Don't wait around till the last minute, so you can have them counted on your midterm grade. So if you guys don't have any questions, I'm done with you. Have a good day, and I'll see you all tomorrow.
Have a good day, Mr. Gardner.
What's that?
Have a good day.
You too, Grant. Sorry, you broke up a little bit there. I couldn't tell what you were saying. So, yep. Have a good day, buddy. Talk to you tomorrow.
You're good.
Talk to you tomorrow.